Okay, so um, I'm just going to do some basic nuclear problems. Do a couple of them to show you. First, just basics. Um, for lithium, a nuclear, it would look like this. 6 Li 3. So basically what this means is that this number here on top is nucleons, and this number is the number of protons, and it's also the atomic number. So the protons and the neutrons have to add up to the nucleons. So you know there's 3 protons and there has to be 3 neutrons. So that's the basic setup for that. To find the mass defect, you have to know the mass of lithium, which is 6.941 is the mass, and you want to find the defect. So first, what you have to do is you have to take the number of protons, which is 3, and multiply it by number, which is 1.007277. Oh, can't see it. And this is a general number that you're going to use. And then you're going to take the number of neutrons, which is also 3 in this case, and multiply it by 1.008665. And you'll use these numbers for, you use this number for the neutrons always, and this number for the neutrons always. And then what you do is you'll add these two products and subtract that from the original mass, and you'll get the mass defect, which in this case is 0.893174. That's the answer. That's the mass defect. So that would be lithium. Now we'll do a different one. We'll do one that has a different. We'll do beryllium. There's beryllium 9,4. So there's 9 nucleons, 4 protons, which means there's 5 neutrons. So to find the mass, well, first the atomic mass is 9.012182. So that's the atomic mass. Now we're going to plug the protons and neutrons into the equations. So for protons, it's 4 times 1.007277, and for neutrons, it's 5 times 1.008665. And then you'll take the sum of the two products and subtract it from the original atomic mass to get the mass defect, which is 0.060251 is the answer for beryllium. And I'll just do one more. Um, 96 and 42. Okay, so 96 nucleons, there's 42 protons, which means there's 54 neutrons. 54 neutrons. So now what you do is you'll get the atomic mass, which is 95.96. Yeah, 96. And then you'll plug these two numbers into the equation. So you have 42 protons times 1.007277, and then the neutrons, which was 54 times 1.008665, and then again just multiply both of them and then add the products, and you'll subtract from this number up here, which is the atomic mass, and the mass defect will be 0.813544. Mass defect. Oops.